The first reaction I will be discussing is the iron and iron thiocyanate equilibrium. The Fe3 plus ion is a clear / see-through ion, and the SCN minus ion is also a clear and see-through ion. However, whenever these two substances react, the Fe SCN2 plus ion turns a dark, rich, reddish, brownish color, almost maroon. Now, this color change is due to the fact that when the reactants react together, they make these two products, and these two products just happen to be a very dark red or maroon shade. And that is how we know that a reaction has occurred. Now, when you add heat in this reaction, it means that the reaction is going to shift this way towards the reactants or towards the left. Now, this also means that the reaction is exothermic because heat is part of the products. So when heat increases as a product, it shifts the reaction towards the left, and when heat decreases as a product, it shifts the reaction towards the right. And if it's shifting this way, it'll make the reaction darker. If it shifts this way, it'll make the reaction lighter. Now, there are also some other color changes that occur when the reactants are added into this solution. So, if FeNO3 increases, then the reaction will shift this way towards the right and towards the products, which means it'll be like a very deep kind of brownish reddish shade. But if the SCN increases, it'll also shift towards the right. However, because of the KNO3, it will become more of a very dark red kind of winish shade. Now, when you add silver sulfate into the solution, it'll increase the NO3s on both sides of the equilibrium. And when this happens, it'll throw it off, so it'll seem like the SCN minus has decreased. And since it'll seem like the SCN minus has decreased, that is actually due to the fact that the SCN will react with the silver to make a silver thiocyanate precipitate, which is the precipitate we see at the bottom of that reaction. And so basically, the SCN minus is taken out and put into the precipitate, which is why we see the solution change into a different color. Now, for my next reaction that I decided to discuss, it was the bicarbonate carbon dioxide equilibrium. So, whenever you aspirated this reaction, it caused this CO2 to decrease. Now, CO2 was the gas that was removed whenever it was aspirating, which is why we are decreasing the CO2. But since the CO2 is decreasing, that means the reaction is shifting towards the right or towards the products. Now, whenever you shift the reaction towards the right, that means that the NaCl and the H2O would be increasing. So since there's an increase of the NaCl, that means that it will turn to a neutral solution because NaCl is neutral and these have reacted to make these products. So there's no longer those reactants. For my final equilibrium I will discuss, it is the chromate and dichromate equilibrium. So as you can see, the chromate ion is yellow and the dichromate ion is orange. Now, when in equilibrium, the orange dichromate and yellow chromate mix together to form a lighter, more ambery kind of orange shade, which is what you see in the first portion of this reaction. And also leads to the change in color when you add an acid or a base to this solution. So now, if you're adding in HCl, it is going to make the hydrogen ions increase. When the hydrogen ions increase, it will end up shifting the reaction towards the right or towards the products. So, since it's shifting towards the products, it will make a more orangey shade, since that's what dichromate is. It's shifting in favor of the dichromate. But when you react it with a base, such as sodium hydroxide, the OH minus of the sodium hydroxide will react with the hydrogen ions and actually make them decrease, since they are being reacted with a base. So those hydrogen ions are decreasing, which is going to make the reaction shift towards the left or towards the reactants, and which is why when you add the base, it will turn a yellowish type of shade, because it shifts in favor of the chromate ion rather than the dichromate ion.